Analyze the chemical role of species X in the generalized mechanism. In the given reaction mechanism, species X is consumed in the first step and regenerated in the second step. X plus O3 gives XO plus O2. XO plus O3 gives X plus 2O2 because X facilitates the conversion of ozone to oxygen gas, but is not consumed by the overall reaction. It acts as a homogeneous catalyst. Understand how chemical similarity relates to the periodic table. Elements in the same periodic group, vertical column, share identical valence electron configurations. Consequently, they exhibit highly similar chemical properties, bonding patterns, and reactivity. Analyze the original catalyst. The original catalyst in the atmospheric ozone decomposition mechanism is chlorine, Cl. Chlorine is a member of group 17, the halogens, and has 7 valence electrons, allowing it to easily form highly reactive free radicals, Cl to the power bullet, that attack ozone molecules. Identify the matching group member from the choices. Looking at the options, bromine, Br, is also a halogen belonging to group 17, located directly below chlorine on the periodic table. Because they belong to the same group, bromine has the same valence shell structure as chlorine, readily forms highly reactive free radicals, Br to the power bullet, and is chemically capable of decomposing ozone through an identical catalytic pathway, forming a Bro intermediate. Conclude the correct option. Bromine is the most suitable alternative catalyst, making option B the correct choice. The correct answer is option B, Br.